when you're calculating masses from equations, there are only three things you need to consider. Moles and mole ratios can be used to calculate the amount of substance reacting and the products formed. The moles and the mole ratios. If you cannot get these moles and mole ratios from anywhere, apart from one, the step that says steps in the calculation, write down a well-balanced equation. That's number one. Well-balanced equation. Two, this is where you get the mole ratios from. Well-balanced equation, that's where you get the mole ratios. So here they are continuing to say that this requires that a correctly balanced equation is written, such equation is known as a stoichiometric equation. A correctly well-balanced equation is what we call a stoichiometric equation. Now here they are saying stoichiometry is a relationship between amounts of reactants and products in the chemical reaction. Then here they are saying a stoichiometric equation is an equation in which reactants and products are correctly balanced. So here they're saying steps involved in the calculations, write a well-balanced equation. Now, this is the basis of chemistry when we started this thing. If you cannot write a well-balanced equation, then it's going to be tricky. Also, coming up with a balanced equation, you must know the correct compound first before you come up with the equation. Compounds is like lead nitrate. You find the lead 2 nitrate like that, which is 1. If you're forming a compound, this one, there is ion exchange, the power exchange. So we find lead nitrate written like this. If you write a wrong compound, then the equation will never balance in chemistry. That is one way. 2, write down the number of moles of the substance that concerns the question. Number of moles that concerns the question. I'm going to elaborate more when you come to equations down there. Then 3, convert moles to grams. Convert moles to grams. Now, basing on the prior knowledge of converting moles to grams, if you started the mole concept with us, there is that conversion of moles to grams. We looked at it. They give you certain moles, you convert to grams. The relationship is also 1 and none other than 1 mole is equivalent to the relative atomic mass of the substance, or relative molecular mass if it is for molecules like these ones, or relative formula mass of any given substance. All these mean the same thing, the 3. So as long as that 1 mole is equivalent to relative atomic mass of that is all. You have converted. So let's start with this. Calculate the mass of iron 2 sulfide formed by heating 6.4 grams of sulfur with excess iron fillings. Now, if you don't know the equation of reaction between that, then that question will defeat you. They are saying the mass of iron 2 sulfide formed by heating 64 grams of sulfur with iron. They have heat iron, which is a solid, plus sulfur, which is a solid, to give us iron 2 sulfide. It means iron is 2, a sulfide is also 2. So these ones cross out and leaves us with that formula as that. If you try to balance 1, 1, everywhere is 1, 1. That is the end of the equation. You have written a well-balanced equation. 2, they are telling us, write down the moles that concerns the equation. Write the moles that concerns the question. So see here, what they are trying to mean is, if the question is saying, calculate the mass of iron 2 sulfide, the mass of this is what they want. This is what is wanted. And they have given you sulfur here, not iron. Don't struggle with iron. Struggle with sulfur and this. That is all. And what helps you is the mole ratios. So what you write is 1 mole of sulfur produced 1 mole of iron sulfide. That is all. That's what they are saying here. Write down the moles that concern, moles of substances that concern the equation, moles of substances that concern. So here, there are only 2 substances that are concerned. It is iron and sulfur. They have given you sulfur, they want the mass of iron too. They have not given you the mass of iron, so leave iron alone. Write this and this. So you go to the table that has the relative atomic masses. 1 mole of sulfur is equivalent to 32 grams of sulfur. Okay, if you don't have the table, I don't know ways we are going to get it, but sulfur is 32 grams. That's the relative atomic mass of sulfur. So 32 grams of sulfur produced 1 mole of iron 2 sulfide. You have to look for the relative atomic mass of this substance. Iron is 56 plus sulfur, which is 32. So when you add this plus this, what do you get? 56 plus 32?
88.
88. Thank you. So 88 grams of iron sulfide is formed when you heat this 32 grams of sulfur with iron. So you write the same statement. What about 1 gram of sulfur? It has 88 divided by 32 grams of iron sulfide. What about the mass of sulfur given, which is 64 grams of sulfur? It gives you 88 divided by 32 times 64. What is the answer there? Yes?
176.
176 grams of iron 2 sulfide is formed just burning 64 grams of this and iron. Have we understood all the steps? So this downer step is converting moles to masses. That's what they are converting, moles to masses. We have used moles from our Roman 2, which says moles that concern the question. Then from here, what followed is converting moles to masses. Moles to masses. 1 mole of sulfur is 32 grams. 1 mole of iron 2 sulfide is 56 plus, which is 80 grams. What about the grams they asked for in the question, which is 64? It gives us those ones. Are we in class?
Yes.
Wendy,
Yes.
you are there?
Yes, teacher.
Okay. Let me, Esther. Esther,
Yes, teacher. Yes, teacher.
we're in class. Yes? Okay.
Yes.
Thank you for being attentive. I'm going to shift to next number. Yeah? Who is talking? Please.
I'm not getting you well. My network is not okay.
What
Yes,
am I going to do?
on and also I didn't get that. The thing
Okay,
you were teaching.
okay. The thing is, when you go to whatever, you'll get this video there immediately after the lesson. Okay?
Okay.
So when you fail, you tell me and I get somewhere to find you. Otherwise, getting lost at this time is very bad. Sheena is also on and off. Sheena, make sure you download the video and you watch in case your network is disturbing.
I do not understand anything about it.
Eh? Who is talking again? Peace.
I'm not talking.
There's somebody who was saying she was not understanding. Who is that one? Eh? Okay. Let's go to the second number. What is the mass of magnesium required to form 55 grams of magnesium oxide? Now here, you are going to write the equation of reaction between magnesium and oxygen. Magnesium and oxygen will get back to work. Someone is going to give me that equation, a well-balanced one. 1 minute, we write it down. Magnesium and oxygen to form magnesium oxide, a well-balanced equation. Let's write it. Because that's our first step, is to write a well-balanced equation. Magnesium and oxygen to give us what we call magnesium oxide. Let me ask it from someone. Cynthia. Cynthia. Cynthia, magnesium and oxygen, give me a well-written equation. Esther. Esther.
Yes, teacher.
A well-balanced equation.
Yes, teacher.
A well-balanced equation. Okay. Well-balanced equation.
Mg plus O2.
Mg plus O2. Yes.
Equals to Mg2O.
M. G.
2
2.
O.
2O. Like that.
Yes. Yes.
Now, I don't know if you are going to cross over to the other laws. The problem is equations. This is a wrong compound. Who can correct this?
It's MgO.
MgO. Correct. Now, is this equation balanced?
And then you balance.
Okay.
No.
Help us balance. Not this.
Magnesium has 2 molecules here. Okay, Cha, you put 2 on magnesium oxide as well.
On magnesium oxide as well. That is all you need. Now, somebody who doesn't know how to come up with equations, we have that video also. Don't waste data looking for other things on the phone. Go straight to the videos we started with, the formation of ionic equation. It is there in one of the videos. So make sure you get it and come up, because it starts from writing an equation like this, then you go to the ionic. Is it clear?
Yes.
So don't spend time on other things, just go straight. I told someone here that after this, what is coming is no longer called the normal education. You have time to benefit from here. Make sure you benefit. What is coming is no longer education. You are going to see. They will just tell you copy notes. Next example, copy notes. Yeah. Next paragraph, continue. Whether you have understood or not, you have to do exam at the end of the year. Is it clear? So make sure when you are here, work hard. We are not going to follow you from home that you did not do this. That is not whatever now. Make sure you learn to manage yourself. So if equation is a problem, make sure you get those videos before and you look at them and see how people came up with those equations. Whatever you fail to ask, we are always there on WhatsApp. You can ask. Okay. Especially you semi-candidates, you are on a harsh side of life, very harsh. Make sure if you're at home, you also behave like a semi-candidate. Okay. So if that is the case, let's go on. This is our well-balanced equation, the first stage. After writing the well-balanced equation, what follows? What follows? Yes? What follows after writing a well-balanced equation? If you look at Roman 2 is saying, write down the moles of substances that concern the equation. Somebody tell me what is so important here? In our reactors, we have magnesium and oxygen. Which one are they talking about in the equation?
Magnesium.
And what?
Magnesium oxide.
The magnesium and magnesium oxide. So we are not going to touch on anything about oxygen. We leave it the way it is. We talk about magnesium and magnesium oxide. So what do we write down? We say 2 moles of magnesium produced 2 moles of magnesium what? Oxide. What follows after that is to convert the moles to masses, convert the moles to grams. That is all. Magnesium, its relative atomic mass is 24. So you say there are 2 moles, not 1. So this is 2 times 24 grams of magnesium produced. Now this is 2 times magnesium oxide, which is 24 plus 16 grams of magnesium oxide. So 2 times this, you get what? 48 grams of magnesium produced. 2 times 24 plus 16, you get what? 24 plus 16 times 2?
64.
This one. 24 plus 16. All times 2.
Yes.
You get what?
64.
You use the calculator well. 24 plus 16.
That is 40.
40 times 2.
8.
So produced 80 grams of magnesium oxide. So the question is telling us, what is the mass of magnesium required to produce 55 of magnesium oxide? Now at this stage, they want the mass of what? Magnesium, not the one of magnesium oxide. They have given us magnesium oxide. So you rewrite this equation starting with magnesium oxide. Okay? You say 80 grams of magnesium oxide was produced by 48 grams of magnesium. What about 1 gram of magnesium oxide is produced by what? 48 out of 80 grams of magnesium. Question comes, what about 55 grams of magnesium oxide? What does it produce? 48 divided by 80 times 55. What is the answer there? Hmm? Yes. Calculators, where are they? Mm-hmm. It is
33
33 grams of what? Magnesium.
magnesium.
Okay. So that is how you come up with this.
Excuse me, teacher.
Yes, you're excused.
The first part whereby you say 2 moles of magnesium
Mm-hmm.
produced 2 moles of magnesium oxide.
Mm.
Yeah, I thought you were supposed to just divide the moles, making them 1.
Yeah, you can do so, but we saw it as a wastage of time. It is also okay if you do it that way.
Okay.
Mm. There's nothing that changes. Actually, you're supposed to divide by 2, say you remain with the 1. That is just a different way of what? Killing a mosquito. So, yes. So here they're telling us that let's look at number 3, and then we go to, I see even we have few minutes to finish. They are saying calculate the mass of copper formed. Calculate the mass of copper formed when 32 grams of copper oxide, copper-2 oxide, is completely reduced to a metal by hydrogen gas. So what are the two reactants? Is what and what? The two reactants? Mm-hmm. Yes, Patricia.
Copper and copper-2 oxide.
Copper-2 oxide and
Copper.
you understand the question very well. The mass of copper, they want the mass of copper.
Hydrogen.
Yeah, thank you very much. And hydrogen. And hydrogen gas. So what are the end products? The end products is copper and what?
Water.
And water. This is a liquid, this is a solid. If you try to balance 2 hydrogens are there, 1 oxygen, 1 copper. The equation is balanced. 2, write the mole ratios of what concerns. They want the mass of copper. They have given you copper oxide. So you consider this and this one only. So here you say 1 mole of copper oxide produced 1 mole of copper. So when I say 1 mole of copper oxide, if copper is 64, oxygen is 16, 1 mole of copper is equal to what? Hmm? 1 mole of copper is equal to how many grams? Where's Letitia?
80 grams.
80. Is it 80? 80 grams of copper oxide produced 64 of copper. So what about 1 gram? The same as 64 divided by 80. What about how many? 3 point what? 2 grams. This is the same as 64 divided by 80 times 3.2. What is the answer? Wendy? What is the answer, Wendy?
I'm still calculating.
Press the calculator very fast. 64 divided by 80.
Time
3.2.
2.56.
2.56 or 2.6 grams of copper, all the same things, grams of copper is formed. How many grams of water are formed? Yes? So we look for the grams of water formed here. Grams of water formed when 3.2 grams of copper oxide is used. How many grams of water? Let's work it out. We have less than 6 minutes to go. I want the grams of water. You are going to consider copper oxide and water. Let's try to hurry. Let's try to hurry. Maya, what is the answer? Okay, I've seen. Thank you. Whatever you have sent is correct. Esther. Esther.
So
My network had just gone, so I don't know what's happening.
Hey, this is Esther asking.
Me too.
Even
Yeah,
peace.
my network had.
Yeah, I've just come back.
They are calculating the mass of water formed when 32 grams, 3.2 grams of copper oxide is completely reduced by metal, reduced by hydrogen gas. They want the whatever's here. The grams or the mass of water formed when 3.2 grams of copper oxide is completely reduced to a metal by hydrogen gas. Our equation is here. Just substitute and get. Cynthia, where's the answer? Yeah? Wendy. Huh. Wendy, what are you writing? Where is the answer?
Samia, I don't know.
Yeah?
Confused.
Who is confusing
I
you?
don't.
Use Wendy.
Yes, teacher.
Follow this procedure. They have given you copper oxide, which is in the equation here, 3.2 grams. So make sure you start from here. You have the relative formula mass. Write the moles that concern. 1 mole of copper produced 1 mole of hydrogen of water. Then look for the relative atomic mass of water. Look for the relative atomic mass of copper to oxide. Copper oxide is given. The one of water is the one you're supposed to look at. Then what does 3.2 grams of copper oxide produce? Is that one hard?
So let me
Wendy,
try.
please work fast. Time is going. I've seen 2 answers. And so those of you who have finished, is this exercise here. Try as much as you can to do it. You can take a snapshot or do whatever you want, or you can copy if you are fast. There are 5 numbers. Try to follow those rules. So that is what you will do. So today we are 87. The t-shirt is okay. That answer is correct. Today we are 7. Next time we shall be 2. Another time, then you see how long the topic will be. Let's try to maintain our number. Letitia.
Yes. Yes.
We'll try as much as possible to maintain our numbers. Okay? So that at least we move at the same pace. If we allow only a few people to attend lessons and then the rest don't, it is very bad. When do you have got the answer? Wendy?
Teacher.
Yes. That
I've
is
sent it.
correct. That is correct. Now you are passing. Where did you get the answer from?
Teacher, I explained.
So stop fearing chemistry. You follow the instructions. All the things are okay. I've seen now that's the correct answer. Okay?
Yes.
So
Yes.
the exercise is here. It is here. 1 to 5. Take a snapshot. A snapshot or screen cover or what? It's called a screen cover.
Screenshot.
Yeah, take a screenshot.
Teacher, screen cover.
A screen cover. It's
Teacher, this is screenshot.
so take anything you know. So this is our exercise for today. And our lesson stops here today. We have not even reached our main point of discussion for today. So have you finished?
Yes, we are finished. I finished.
Okay. Now you know my number. Make sure you send the work there. I will mark. Is it clear? Yes?
Yes.
Is it clear?
Yes.
Okay. Now on Saturday, we meet and start on this work and make sure we finish all these laws here. These 2 laws. This man here and then this other man called Avogadro. When we finish this, and you cannot calculate numbers in the mole concept, then you know that we have a booklet of, who has seen that booklet? The booklet is here. I'm going to show you that booklet. We have more than mole concept problems are here. Do you see something on your screen close to that? Yes? Yeah?
Yes.
So these are about, if you're not mistaken, 200 and something mole concept questions. 200 and something mole concept questions only for you to calculate. After the topic, 210. After the whole topic, I will send you this and make sure that every day we meet, you present 10 numbers before we go on. Is it clear?
The numbers.
Yes, each person has to do one, but make sure you calculate. Me, I will pick at a random. You are giving us the answer and how you came up with this, whatever. You explain. Don't be scared. All these things are easy. As long as you start the mole concept well. So make sure you attend on Saturday. Is it clear?
Yes.
Yes.
That's the sample of number one. You can take a screenshot also and be trying out. So, take a screenshot and be trying out.